Hi everyone, welcome back to our YouTube channel, Becoming a ROS Developer here at The Construct. My name is Rodrigo, and today we have one of our students, Hrishikesh, who has completed our course, ROS 2 Basics in 5 days. And at the end of this course, there is a project you can complete in order to get a certificate. And this project actually is implemented on a real robot. So that is what we're going to be seeing here today. Hello, Hrishikesh, how are you?
I'm good. How are you?
I'm good. I'm excited to see your screen. To see your project. So whenever you want, you can share your screen and show us how you've done your project.
Okay. Is it visible?
Yes, we can see your screen now.
Okay.
Okay, so we see the robot moving. Can you kind of give us a little bit of a explanation of what's going on?
It's kind of stuck right now. Was working a while ago.
Let's just give it a second.
Yeah.
Um, are you able to move the robot with the joystick?
Let me just check.
You should kill your node first, yeah.
Nope. Not able to.
That's strange because we just saw it move. So could you just disconnect and connect to the robot again?
Yeah.
I would just give it a second till it connects.
Mhm.
All right.
Let me just check. No. Okay. It's working.
Okay, great. So now the last thing to load is the web shell. So
Mm.
just give it a little bit. All right. Looks like it's loaded. Great.
Right. This is the wall finding function where it basically finds the right wall and adjusts itself in the range of like 0.3 meters.
Yeah, cool.
And
It went
then
backwards this time.
and then it turns to the left to face the right direction, then starts the wall following node. So basically it's following the node in the range of 0.3 to 0.25 meters.
Great.
And it's using the right laser and the front laser, not exactly the front laser. I use the diagonal lasers to, I don't know,
Mm-hmm.
it make it more in what do you say, concise manner.
Mm-hmm.
And when it reaches the end, it checks the front laser if it's too close, and then it moves left by publishing angular velocity. And yeah, that's the wall following function. And the odometry function is basically first the initial point. It records the initial point, and then as we move,
Yeah.
it finds the distance covered and it adds it to a variable. It adds the distance. The distance is basically like the coordinates when we find the difference between the coordinates and use the square root. We find the distance and then we add it. We keep adding, and
Right.
that the distance function from the odometry, where we subscribe to the odom
So that's what
topic.
we see in the distance covered. Okay.
The feedback from the action odometry action.
Yeah, I see. Let me ask you a little question, or
Yes.
maybe it's luck. How did you do it so we don't have like a continuous stream of distance covered, and it's updating sort of in the same spot? Or is that luck of how the terminal is sized? You know what I'm saying?
Like the what do you say?
Oh yeah, yeah. Okay, yeah. That's what I was meaning because it looked like it was updating, and I know you can do some tricks with the output in Python to avoid that. All right, cool. No, never mind then. And then it says lab completed, right?
Yeah.
So at that point, you kill the node,
Yeah.
and we have a lab completed. I'm assuming you. How did you know that the lab was completed?
The lab complete is basically like when it reaches the initial point in a tolerance of like 0.1. We find the distance between the initial point and the point the robot has reached from the odometry information, and then we know the lab is complete.
All right.
But we
Well,
all yeah,
no,
but
go
we all
ahead.
yeah, but it's only activated after like 5 seconds, so that in the initial stage we don't see it like it's already there. Then the lab is completed. We have to wait 5 seconds and then only check that value.
Right, right. I understand. Awesome. Well, really nice lab there. I'm glad we figured out there was just like a connection thing there. So if you could just little bit go into how you solved each. I mean, I know you talked about this a little bit, but maybe just mention a couple interesting points that of each section that you thought how you solved it, and that's it.
I will talk about the first challenge I faced.
Yes,
There
perfect.
was first in the topic section, there was a problem with the simulation and the real robot. There was a difference between the laser values.
Mm-hmm.
So that was a bit tough to figure out. But what I did was I faced the robot in different directions, checked which array value is the least, and then figured out what the value of the array is in the real robot and the simulation robot. And then I had to change those values and change the value of the right laser and the diagonal laser. And then that was one of the challenges. So basically, in the first wall following function, I used the diagonal values and the right values and made it in the distance between 0.3 and 0.25,
Okay.
and didn't want to go too fast because it would not follow it properly. It would go too much towards the wall or too
Why
much
do you
away.
think that is?
I think it's the frequency of the um, subscription, how fast you can subscribe to the topic. Like,
Yeah, and how fast you're spinning that node,
yeah, how
that
fast. Yeah.
process it. Okay, yeah. So you can adjust that the speed of course up to a certain point, but
Up to a certain point, yes.
yeah, physically possible.
Yeah.
All right. So then you said you how'd you solve that? You solved by putting it in different spots in front and check the least. Was
Yeah.
was only the resolution different, or was also the orientation of the whole thing? Was it also different?
The orientation was different, yes.
Oh, all right. So I think actually in this robot it starts at the back, and it's actually I think it's a default thing in most lidars. I mean, it can change, and that's why we do this because it's always different.
Mm.
Usually they do it at the back. If they put the lidar like this, maybe you want to put the lidar oriented in a different way based on mechanical specs or whatever. So yes, you also have to check the resolution and then where does it start. They all go counterclockwise. I've never seen one that goes clockwise. All right, awesome, great. Are there any other challenges you faced, or
I would say,
anything you want to mention specifically?
yeah, in the wall finding function, first I use the distance to find like in the lidar is an array of course, and when you want to find the least uh, distance, it was kind of hard because for some time the timer sleep function wouldn't work properly. Like I would find the least distance in the array and find the difference between that index of the LiDAR and the front index so that it could turn towards the wall
Yeah.
and apply the timer sleep function in such a way that it goes to the wall in that interval of time. Like
So
use
you
timer.
publish a velocity and then you sleep it
Yeah,
until. Okay, yeah.
until, yeah. But it wouldn't work. It wouldn't work.
That is gonna give you some problems because you're putting a time like a sleep. So you're shutting
Yeah,
it, like
shutting down the whole
you're
thing.
closing your eyes for a second.
Yeah.
Wait, what are some ways you can think of to improve upon this so it's more reliable? Is there anything you can think of that could aid in this?
So what I did was basically like found the index and moved it till the index was in that the front index was the least. Yeah.
But sometimes it would keep going, right?
It would keep going, but that's why I added a tolerance so that it wouldn't just move past it
Oh, okay. A tolerance of speed or of what?
of the index.
So you instead of one index,
I did
you grabbed a
10.
bunch. Oh yeah, that's a good way to do it. Another way I'm thinking just right now is like instead of sleeping it, you can do. Is this ROS 1 or ROS 2? This is ROS
Yeah.
2. I think there is a duration one for. There's a duration function for RLCPY. And so you instead of sleeping, you can do a duration that you figure out how much you want to spin based on where you are, and then do a duration and publish for that amount of time. And that way everything's still alive. That's another way. I mean,
Okay.
just to think about it. And I mean, great. Sorry, I'm interrupting you. I just think it's a little more dynamic if we talk about it like this.
Yeah, it's true. It's good.
All right. Are there any other things, for example, for the odometry recorder? Any things you want to mention or something like that?
Odometry, I didn't. The only thing I faced is, yeah, in the beginning, I didn't really add a function to add 5 seconds so that it would not just initially just say lap completed.
Right.
Then I added it later to add like a delay of 5 seconds so that it would not
It would
count.
start late.
It would start late. And then the odometry was pretty simple. It was just finding the distance between each point from the odometry information.
Uh-huh.
And the feedback was, feedback was the total distance, the current total of the the distance covered. So yeah,
All
it
right.
was
One thing
all
I
right.
can suggest on that point is, see, when the lab completed, I saw you kill it manually. One thing you can do is do the shutdown function
Mm-hmm.
once you receive that result. And
RCLPY shutdown.
yes, exactly. That's
Okay,
a
okay,
way to
yeah.
just put it inside. And of course, you might want to make it go around forever. So it depends. Um,
Okay.
and just last question, just out of curiosity,
Mm-hmm.
what happens if you start your main launch, but you're closer to an obstacle?
It would uh it would align with the obstacle.
So it would think that the wall is the obstacle, and then you need
Obstacle.
to restart it, obviously.
Yeah, I would have to restart it.
Okay.
Yes.
All right. Okay. Good. Perfect. Well, I mean, congratulations, Hirkesh. That's all I can think about. I mean, it looks like a really nice project, really concise, and it shows that you've took the time and understood what was going on.
Yeah.
Again, I'm glad that that first hiccup was just a connection issue because we were doing some special things here for you for your
Yeah.
presentation.
I'm glad it worked.
But anyways, yeah, I mean, other than that, I just want to congratulate you again
Thank you.
and tell you that it's a really good job.
All right. Thank you. Thank you.
All right. So let me just change here the screen. And to anyone else that is watching, you can do what Hirikesh did here and complete your project and come present it to us so we can give you a certificate of learning so we know that you took something out of our course because they are very important to us and they mean something to us, our certificates. So I encourage everyone that is watching to do what Hirikesh did here. And that's it for all of us today here, guys. So we'll see you guys next time. And Hirikesh, thank you again. And we'll hope to see you again for the next project.
Perfect. Thank you.
All right, guys. We'll see you later. Bye-bye. Okay, cool. Hirikesh, we are done.